Hello everyone and welcome to SCOMathon 2026. My name is Stoyan and in this session I want to show you how much you can actually do inside the native SCOM Web Console. The title of the session is the SCOM REST API in action, building web console dashboards for beginners, and the word beginners here is important because this won't be a front-end developer session but a practical one for SCOM people who want to build useful dashboards with minimum amount of HTML and JavaScript knowledge. My goal today is to show you how these dashboards work, show you the REST calls behind them, and then prove in the demo that these are real usable widgets, not just some theoretical examples. Let me start with the agenda. First, I will explain why I chose this topic and what the real world trigger behind it was. Then, I will show how the native SCOM Web Console dashboards actually work. After that, I will cover the REST API essentials. Then we will show how basic samples can be turned into much more practical widgets with the help of AI. After that, I will walk you through a couple of cool dashboards that I've built. Then we will close with best practices and common pitfalls. And finally, I will wrap up with GitHub and the main takeaway. So, why this topic and why now? I have presented SCOMathon every year since the event started, and this year I wanted a topic that feels new, practical, and toward the audience time. A real customer requirement pushed us into native SCOM Web Console dashboarding, and the result was a set of reusable widgets that are far more capable than many would expect. The audience benefit is this. The session is a workaround scenario for teams that still want good operational dashboards, even when a premium dashboard Pro is not an option. The key message here is that the Web Console is not just a simple monitoring view. With the right REST patterns, it becomes a very capable dashboarding surface. And the reason this resonated as a session topic is that it's not a lab-only idea, but it came out of production, pressure, practical constraints, and the need to deliver something that SCOM users really need and use. What will attendees get from the session? First, I want you to understand the model, how custom SCOM Web Console dashboards actually work. Second, I want you to learn the core REST calls, state, alerts, performance, relationships, groups, etc., etc. Next, I want to show how AI can help with layout, cleanup, without requiring deep HTML expertise. And fourth, I want you to see reusable patterns, practical dashboard types that you can adapt to your own environment. So the point is not to watch just a demo, but the point is to leave with some kind of model, a small set of core APIs and patterns you can reuse. So, how native SCOM dashboards work? This slide is the logical model for the entire session. All the dashboards are built and operate the same way. Everything starts with the REST API call. The Web Console calls Operations Manager endpoints to retrieve monitoring data such as states, alerts, performance, groups, and relationships. Then comes the light logic in the browser. The returned payload is filtered, merged, sorted, or grouped so the data becomes easier for humans to scan and act on. And then comes the rendered widget. HTML and CSS turn that shape data into tiles, rows, charts, and links. So the important point here is this. Useful dashboards come from understanding the data flow. So query information, receive information, transform it, visualize it. This is the real pattern. If you remember one technical slide today, let it be this one. Let's start with the core concepts. The typical path of a REST API call, in our case, is Operations Manager /data. The main methods are get and post, and the typical inputs are scope, criteria, display columns, and the time window. One especially important Web Console detail is the CSRF token. Its purpose is to secure the Web Console REST call. You read it from the browser cookie and then you send it back into the request header. In practical terms, that means if the token is missing or invalid, your API calls can fail. Now to the core calls used in this session. First, we have post to data state. This is the basis for group held styles and object state views. Second, we have post to data/alert. This is what allows alert enrichment. Next, we have post to data performance. This powers charts, trends, and explorer style widgets. Afterwards comes the get to data object information with a specific ID. This is critical for hosted and related object scenarios. Fifth, we have a post to data SCOM groups. This helps with dynamic groups discovery. And last, we have a get to data performance counters with a specific ID, and this call is used for counter discovery in more interactive performance widgets. Most of the practical dashboards patterns I will show later come from this surprisingly small set of REST API calls. Microsoft Learn gave the start and AI helped finish the job. The starting point for the widgets we have built together with my customer and colleague was Microsoft Learn. There you can find different custom widgets, models, and very basic examples. That was enough to prove the concept, but not enough to deliver really polished operator views. Where AI helped was in the layout and styling of the data, the code cleanup and refactoring, faster iteration, and turning a rough idea into working user interface. The practical workflow that made this doable was very simple. Start from a minimal working sample or a basic example. Capture and inspect the REST calls in the browser when doing troubleshooting. Ask AI to improve structure, layout, and readability. Then test, simplify, and repeat until the widget behaves well for the operator. And the key beginner message is this. You don't need to be really proficient in coding in order to get this done. Let's see shortly what are the prerequisites for this. In the current environment, the dashboards depend on a small and clearly identifiable set of JavaScript files. jQuery is the core helper library. It is used for DOM work, events, CSRF handling, and SCOM REST calls through Ajax. Canvas is used for the performance widgets and the small multiples dashboards. HighCharts.js is the core charting library used by the alert, health, hotspot, and overview widgets. HighCharts 3D is the 3D extensions used for some of the bar and pie style widgets. Modules exporting.js is the export module referenced by the HighCharts-based widgets. And also I have used the custom PNG file, which is actually my company's logo, in order to enrich the dashboards with the company's logo. The key message here is that the current demo set depends on 5 JavaScript files across the jQuery, Canvas.js, and HighCharts families. And actually, all of the libraries can be very easily found and downloaded on the internet. You just have to open a browser, do the search in Google, and they're free to download. So, before I switch toward the practical part, I want to show you a code walkthrough. I'm not going to explain the widget line by line because this would not just be meaningful. What I want to show instead is the structure that repeats again and again in all of the dashboards. Once you see the pattern a few times, the code becomes much less scary and it stops looking like a web development magic and starts looking like a template if you want to call it so. So let us look at the code of the simplest dashboards, and this dashboards is a state widgets for a group of servers, and I want to cover only the basic part. So this is the title. So I have used a fixed group. This is the ID of the group in my environment. What's important to see here are all the references to the libraries. So if you pay attention here, you see that not the whole server part is here. So the reason for this is because you can actually not use the full server name. It does not have to be written explicitly in every script. You can reference it this way. And of course, the Web Console interprets it like this. So next comes a little bit of HTML magic. I must admit also, I'm not good at HTML. So I used AI for refactoring the views and how they look, changing the colors, the fonts, the sizes, and all the stuff. It was easily done by the AI I used, and it works great. What I want you to see here is also this line, and this line also references the PNG file I have used in all the dashboards. So the file sits in the same directory on my server. I will show you right away how this looks like on the server directly. And this is a PNG file which points to my company's logo. And here you see also a very important line. This is the ID I have used for this widget, and this is the ID of the group I am going to present to you. And the cool thing here, there are some friendly names I have used for the servers in order to easily identify them. You can also use them in the dashboard so that the view looks more natural. So again, some HTML stuff which I'm not fully familiar with, but here the part is actually the load data function is actually the data being transformed and being visualized or being managed properly in order to be visualized on the dashboards. So with this being said, let's continue to our real demo directly on the server, where I can present you with all the widgets I have built together with my colleague and customer, and I really hope you will like them. So let's jump to our server here, and what you see on the screen currently is my demo server, and this is SCOM 2022 with the latest patches, and this is the Web Console. And I have prepared here a folder with the name SCOMathon 2026. And I will start with the simplest of all the dashboards, and this is the server state dashboard. And this is how it looks like. So what you see here, those three servers are actually in the group you saw previously with the ID I have used in the dashboard widget. And all the three servers have also friendly names. For example, DC01 is called the main controller, SCOM01 is called SCOM server, and the SRV01 is the development server. What you notice here is actually the logo of the company used on the dashboards. And in order to show you where the actual file sits, I have created a simple folder on my file system. It's called dashboard libs, which contains all the JS files we already covered and also the company's logo. And what I have done in IIS is I have simply used this folder and created a virtual directory in IIS in order to be able to reference all the files with their paths. Going back to the server state dashboards, all the dashboards are actually having the drill down function. So if I hover the domain controller, you'll see how it moves slightly. And when I click on it, you see SCOM opening the standard view of the server, where you can see all the states of all the objects. You see the information of the server, and you can also go to performance and see some performance counters. So all the dashboards offer this functionality out of the box, and I need to tell you this was the one of the first dashboards we've built with a customer. This was our starting point, where we used this as a template And with the help of AI, we were able to expand it, make it more complex, and you'll see right away in the coming dashboards. So, the second widget or dashboards I want to show you is the server state, which is enriched with alerts. So this is something very cool for operational teams, because you don't only see here the 3 servers and their state. For example, if they're green, this means that the server is healthy. The server could be also yellow if it has a warning state, or of course red. The cool part here is that the servers, they have triggered some alerts in the SCOM console, and you're actually able to see the alerts here under the server state. I found it pretty cool the first time I managed to get it working, and my customer and colleague was also very impressed by it. And this dashboard also has this drill down functionality we saw previously. So the next dashboard set we are going to see here uses the same template for getting the state of an object, but it does not get the direct members of the group, but instead it gets a class which has some relationship to those direct members. In my particular case, my group consists of Windows computers, and what I see here is, with the help of some logic, I'm able to get HostSQL database engines. And what you see on the dashboards also, if you pay attention, is first of all, the color of the server is yellow. This means the server is in a warning state, and you can tell by the alert here. And also the same applies to all the other database engines. And another widget which gets the databases under the database engines. So this nested state widget uses the group I showed you previously. It goes over the group members over the Windows computers. Then it gets all the database engines, and for all the database engines it gets all the databases. So you can target groups of Windows computers, but get the state of objects which are not the objects of the Windows computers themselves, but underlying objects of another class. And as we saw previously, here we have also the drill down functionality, where SCOM opens the health state in an additional tab of this particular object. So next we have some alerts and states widgets, which they were actually very easy to build. So we have alert share per severity. Notice here you could have the refresh option directly here within the dashboards, and you have some outputs informing you about whether the results were loaded successfully, whether there is an issue with the underlying layer. For example, if your SCOM management server is not operational, then you might get an error here. And the rest of the stuff looks very familiar. The company logo, which we have used in every slide, and very colorful charts here. We have also the alert share per severity. We have the health state of Windows computers, and alert trend over time. My servers are pretty green, so currently, let me see if I can do this one. Yes. And now you see the open alerts trend over time, and I can easily play with the days here and select a different time range. And you see what I found really cool is when you hover over the data here, and this was an explicit request of mine, that I'm getting all the open alerts at the particular moment. So that I can identify how many alerts were open at that particular time. And we can build for all the fans of the dark background, the same, I have built the same dashboards, the same 4 dashboards, but with dark background, with very simple prompt on AI, just build me those same dashboards with dark background. And this is how it looks like. All the options, when you hover over the state here, you get how many alerts are there. In addition to the number, when you hover over the pie chart, the same happens. And we have also the alerts trend over time dashboard, and we can see that it works great also in its dark form, so to say. So let's jump to number 6, mini spline charts. The first thing, when we've built this dashboard, let me first go ahead and select a group here. So all the menus here in the selections were AI prompts. So I have not coded this myself. And those were AI prompts. Please make me a field where I can choose the group. Then I want to be able to reload the groups. I want to have also the time range, etc., etc. So let me select our demo group here, consisting of those 3 servers. And what you immediately see here is that those 3 servers are getting displayed with their basic metrics like CPU, RAM, the percent free disk space for all the partitions, etc., etc. And I can also play here with a time span, and it's really very quick and very responsive. And here is the right moment to say something. In the customer environment where we have built this, the environment has more than, I think, 2,000 agents. So it's a very, very big environment. And what I was very surprised is that those REST API calls are so efficient that even with bigger groups, with many members, that actually the data gets loaded very, very fast. So this is the first version of the multiple or mini spline charts, is how we call them. And then I want to show you the improved version. So for this version, we got the code from Microsoft Learn, or the basic stuff from Microsoft Learn. We got it working. And then we decided to make it a bit more prettier and a bit more nice to read. So we've built the second version of the small multiples, and let me show you how it looks like. So I need to select a demo group again here. So this is our demo group. And you see, it's the same display of the data, or the same data set, but displayed a bit more prettier, with more colors, more, let's say, suitable for big screens and for generally for dashboarding. And what you can see here is also the ability to change the range in days. So you can play with the days, or you can also take a start point and end point for the performance counters, which also looks perfect. And you can do, of course, some sorting, for example, like this, and it gets reloaded. And in my personal opinion, this one looks really, really great. So, going further with performance widget old style hard-coded group. What this means is that for this widget, I have hard-coded the group in the code, and I didn't use a group picker like with the previous dashboards, you see. I left this widget because this was the starting point for developing all the rest of the performance widgets that I'm going to show you right away. So what you see here is that you can select for the predefined group of those 3 computers which counter you want to display. For example, I have now the CPU in percent, then I'll take the logical disk, it gets loaded right away. You see the also here we have the all the servers with all the covers and which cover corresponds to which partition, so that you can easily identify them. But when you hover over the dashboard, you can also see, or over the performance metrics here, you can also see not only the values, but also for which server this is and for which partition. And we have some other cool stuff here, like you can select individual servers like this. You can also select them all if you want to. Then you get all displayed. And actually this was the starting point for all the rest of the performance widgets. And let me show you how those look like. So this performance widget is showing us performance counters for single server, and it's showing the values for a single counter. So I'll select the group here. So it's not a static group which is hard coded here, but you can select one. So I will do so. Let me find my group. It should be right here. And then I need to select computer. So let me select one computer. I have intentionally left this performance widget like this because it was the second step of optimization. So we were able to select different computers here. And I want to select which object type I want to visualize. Let us pick processor or memory. So then I have the opportunity to select the counter. Like, you know, the object type memory, it could have different counters. So here I could take, for example, available megabytes, and right away it gets displayed. So you can also select the time range. Let's increase it to see how it looks like. And you can take a start and end date for this dashboard. So this was the second step. And now going to the third step, where we took this even further and make it even more complex and stunning. So what you see here is a performance dashboard, which gives you the opportunity to pick a group. Let's do that in order to show how this works. So let's take the same demo group we saw previously. Then what I have here is the option to choose one computer, one single computer, or multiple computers. So let me pick them all. And what you see right away here is that as soon as I select the desired computer, I get also the state of the computer, including also the alerts. So this dashboard is not only performance dashboards, but it combines performance metrics with states. And let's go to the object type. And here, what we are going to do, we are going to select multiple object types. So I'm going to select memory, which is pretty standard. I'm going to select processor, and I'm going to take, for example, logical disk. Let me see where it is. Network adapter, processor information, and logical disk, of course. So I have selected 3 object types. Now we are going to the counters. We have selected 3 object types, and you see under each object type, you have the corresponding counters for selection. Let's take one of the counters, memory available megabytes. As soon as selected, the dashboard begins presenting those counters on the widget. But you need to watch out what happens if I increase the selected number of counters and I take other counters. For example, I have now selected available megabytes memory, and I want to also add logical disk % free space. Look what happens when I select this. The dashboard automatically switches from single object type, single counter, to multiple object types with multiple counters. And this costed us really a couple of hours of try and fail until we got this working. And I want to show you how great this works if we increase, for example, also here the counters, take other counters to see how good it looks on this dynamic multiple state view. So I would say this dashboard or this widget was the most complex widget we've built. So it could show you the server state, also the alerts of the servers. It could show you one counter for one object type or multiple counters dynamically for multiple object types, and very clean, very also pretty, in my opinion. So I did play with my AI, and then I asked it to generate the same dashboard but with a dark background, and this is how it looks like. And here we have absolutely the same functionality where we can select a group, and we will select our demo group, of course, here, and we have, of course, the same options here. So I'm going to select the counters, and actually all the menus here are absolutely the same. It's just a dark background. And now to the last widget I want to present to you today. I decided to experiment a bit with my AI model, and I asked it, I gave it a prompt, knowing all the dashboards we have built over the time, to go over them and give me a suggestion of what I could do next. So I called this last dashboard AI Imagination because I didn't give it any particular hints on what to build. It just built something for me, and it looks like this. It built me an operations pools overview where I can see the computers in scope. So this is scope to my particular group. How many are healthy? How many open alerts? Oldest open alerts, and some nice charts here. If I go down, you'll see also open alert age. This is a very interesting detail here on the dashboards, and you have also a list of the most recent alerts. And the second widget the AI built for me with this prompt is the alert hotspots by computer, where you get alerts per computer, which is actually a very nice overview for operational teams. So this was built simply by my AI model without any specific prompt, of course, after it got to know my other dashboards and all the details I need in them. And with that, our demo is coming to an end. I have one more detail for you that I want to show you. And let me jump back to the slides. So we have also a slide on best practices and lessons learned. After the demo, those are the main lessons I want to leave with you. On the best practice side, start with a very small working widget and extend it gradually, step by step. This is my first advice to you. Keep the REST queries scoped and efficient. Request only the data you really need. This will really have an impact on performance. Refresh responsibly, so you don't have to create self-inflicted load on your dashboards or on your systems. Design for readability first and cleverness second. Of course, test against real operator workflows, not only technical correctness. And of course, clean up before publishing anything to GitHub, because you might have some environment-specific related data within your dashboard. On the pitfall side, do not try to show too much on one screen. Although we might have done this with the complex performance widget, which shows the state and the alerts and all the counters, I think it still looks good, but you need to keep that in mind. Do not ignore hosted objects relationships. Those are important. This could play a key role if you want to show the different classes under the Windows computer class for a group which consists of Windows computers. So Avoid hard-coded environment-specific values whenever possible, of course. Be careful with large datasets that hurt browser rendering. And do not treat the user interface as an afterthought. But the biggest lesson is actually this. Start from the operator's decision-making need and then work backwards to the REST code and the UI. And the last slide for today, let me close with GitHub, the main takeaway and question and answers. The code sharing plan is to publish the dashboards in a GitHub repository after customer-specific parts are sanitized. In this case, they are not customer-specific, but are specific to my demo environment. So I want to clean them up and then prepare them like a template, which you could use. The goal is to provide reusable snippets and patterns for the whole community to use. The repository idea is simple. I will provide the screenshots, setup nodes, prerequisite, and version nodes for the tested SCOM environment, so that if you want to use them, so that you know how you can set them up, how, for example, to where to place all the libraries, etc., etc. And the main takeaway from the whole session is this: you don't need to be an HTML developer or have deep HTML skills in order to build useful SCOM Web Console dashboards. If you understand the REST codes and use it properly, you can achieve it without any effort. Of course, some AI-assisted approach is required here. I've also done it, and nowadays it works really great with the latest version of the models. They're providing really ready-to-use code, so this helped me also a lot. And with that, thank you very much for your attention, and I'm happy to take your questions in the chat. Thank you very much.